Hello everybody. Now remember in the last video we talked about proteins and different types of proteins and how proteins fold and why protein shape is essential for protein function. And at the very end of the video we mentioned that one of the functions proteins can have is to be an enzyme. And remember we said that enzymes are proteins that speed up chemical reactions. So in this video we're going to be looking at more about how enzymes work. So let's talk a little bit more about enzymes because they're so important. So we already said that the function of an enzyme is to speed up a chemical reaction, and it does this by decreasing the activation energy. And we'll talk about what that means a little bit more in a second. So some important things about enzymes is during a chemical reaction, they don't change, right? So enzymes don't change into a different product, and they're not used up. So this means we can use enzymes over and over and over again for the same chemical reaction more than once. So we just said that enzymes work by lowering the activation energy. And what activation energy is the energy needed to start a reaction. So I want you to kind of imagine if I had molecule A and I was combining it with molecule B and I was doing a reaction where I was trying to turn that into molecule C, it takes a certain amount of energy for this to happen. So how enzymes work is they lower the activation energy. In other words, they make the reaction easier to happen because you don't need as much activation energy to get it started. So I have a graph that shows you this. So I have energy on this axis and the progress of the reaction on this axis. So you can see without the enzyme, you have to put a lot of energy into a reaction to get it going in order for it to form the products. However, if I have an enzyme, I need a lot less energy in order to get the reaction going. So therefore, this reaction's easier. I don't need to put as much energy in to get it started. So let's talk about how enzymes work. So if I use that same example, my A plus B are combining to give me C. The molecules that are going to bind to the enzyme, the molecules that the enzyme is acting on, are called the substrates. So in my example here, A and B are the substrates, right? And then C is going to be my product. That's what I'm making. And then the specific spot on the enzymes where the substrates actually bind to is called the active site. And I'm going to show you that a picture in a second. And basically the way enzymes work is they position the substrates in a perfect way so the reaction is able to happen faster. And I think this will be easier to understand once we see a picture. Okay. So here I have a reaction. So what we're looking at here is I have a substrate. In this case, it's a disaccharide, and I am trying to break down this disaccharide. I'm trying to use hydrolysis, so I have to add water to it. So if I add water to my disaccharide, it's going to break that bond right here, and I'm going to get my two monosaccharides, glucose and fructose. So it turns out it takes quite a bit of activation energy to break this molecule down. It's not really going to happen on its own. So therefore, we need an enzyme to speed up this reaction. So here's my enzyme. This enzyme is called Sucrase, ASE, so we know it's an enzyme. And it's called that because it breaks down sucrose. That's why it's named that way. And the way this is going to work is my enzyme right here binds to my substrate. And where it binds is called, that portion of the enzyme is called the active site. So you can see my enzyme is binding to the substrate. And then right here, you can see the substrate is binded in at the active site. Now my enzyme bends in such a way that it makes the sucrose break really easily. In other words, it's lowering the activation energy, making it easier for it to break. So when water comes in, the molecule breaks really easily, and then I get my two products. And again, this reaction would have happened much more slowly. Maybe it would have even taken years or hundreds of years for the reaction to happen without the enzyme. So it turns out enzymes can only catalyze on one particular reaction. So in that example we just looked at, that sucrase enzyme can only break down sucrose. It can't do anything else. It can't break down lactose. It can't break down maltose. It only breaks down sucrose. So enzymes are specific, meaning that their active site only fits with one substrate. And the theory that we use to explain this is called the induced fit theory. And it's the idea that enzymes have a general shape and only a certain substrate will be able to bond to their active site. And if only a certain substrate can bond to their active site, then they can only catalyze one reaction. So remember we said that a protein's function is essential for its its shape is essential for its function. That's really explained here by the induced fit theory. So finally, to kind of summarize, enzymes are super important. There are millions of different enzymes in your body. Every single reaction you do is catalyzed by an enzyme. So they regulate chemical pathways, they synthesize all new materials cells need, they speed up chemical reactions, they regulate chemical reactions, and without enzymes, most reactions would occur too slowly to sustain life. In fact, most reactions would take years, if not longer, if we didn't have enzymes.